Okay, let's talk about completing the square, and as always, please remember this is a recap video, so I'm going to be talking quite quickly, so pause the screen and slow it down if you need. Now, completing the square is not taking squares and making it into little animals, I wish, but it's actually completing squared brackets like this one. That x plus 4 squared is a completed square, so we generally are trying to create those. But we're creating it from what's called the distributed form. If you write that bracket out twice and FOIL it, or distribute it, you're going to end up with a trinomial, and that is where we need to start. The trinomial is what we're given, and we need to get back to the completed square. Now the secret is in the number in the bracket. You see that plus 4 over there? That plus 4 has an interesting relationship with the middle term in the trinomial. It's doubled, and also has an interesting relationship with the last term. It's squared. And that's always going to happen when you come out of the bracket squared, as long as that first letter is just an x. You're going to double to get the middle term and square to get the last. And that then allows us to be able to go backwards. It allows us to start at the trinomial and use the double and the square relationship to get back to the completed square. So have a look at this example. You see that 6 in the middle? Well, we know it has to be half in the bracket, so it would be a 3. And if you were to square the 3, you would get the 9. So that's the correct number. Please notice that it's a negative because it was a negative 6. In this next example, we're going to have a 10. So in the bracket, it should be a 5, a positive 5 because it's a positive 10. And that would give you 25 if you squared it. So the summary is, to get the perfect square bracket, as long as that x is just a 1x, you just halve the middle term and make sure that it's squared. Okay, so what we need to ask ourselves is what's going to happen if the c and the b don't have that relationship. If the c is not half of the b squared, then what do we do? Because then it's not a perfect squared bracket. Like in this example, that 5 doesn't work. If you try to put this into a bracket and you use the 4, which is half of your 8, it doesn't square to give you the 5. So what do we do? Well, remember that to go into the bracket squared, you take that 8 and you halve it, b over 2. And then if you squared it, you'd get 16. So 16 is actually the third term you need. So you put the 16 there, you see, in the place of the third term. Then you still got the plus 5, but your equation's unbalanced. So just go and subtract 16, because then you're going to keep your equation nicely balanced. Now the first 3 terms are going to go into that perfect bracket, and then the 5 and the 16 can just add at the end. There's your completed square bracket. So just go over those steps again. Number 1, you had to add this third number, which is half of the b squared. Then you just had to balance by subtracting it again. And then you had to take the 3 terms and put them in the bracket squared like we were doing earlier. So that works great. Just one little note. If you have a number in the front of your trinomial, you need to first take that number out of your trinomial as a common factor. Then you can go and get a third term. What's 12? Divide to 6 squared. 6 squared is 36. Balance it. There it is. And then take the 3 terms in that bracket, complete the square with them, simplify the rest of the numbers, and then you're going to have to times that 2 back into the bracket. Okay, so that is a little summary of completing the square. Please remember that this is used in different sections, functions, analytical, some hard algebra questions. So take some time. Pause the screen and rewrite these notes carefully.